Hey guys, I hope you enjoyed your break. Welcome back. Today we are going to do lesson 4. So, under modules, you're going to come over here, click on lesson 4 journal slides, and we need to add these to our journals. So, you'll click go here. It will open up this slide. You can do Control C. Once you click on that side, you can do Control C, or you can right click, which is clicking with 2 fingers, copy, paste this into our journal, okay? Make sure your journal is up to date. You guys noticed um, at the end of the 9 weeks, we grade journals. It is a test grade, so make sure you're keeping your journal up to date. Okay, so I'm going to go ahead and either do Control V to paste it in, or right click and paste. Just right click on that last slide and you can paste, it'll paste it right in, okay? Make sure your table of contents is up to date. So this is Unit 3, Lesson 4, Graphing Linear Inequalities. Okay. To link this, you're going to highlight it, insert link, slides in this presentation. We're on slide 7. So I'm going to scroll down and select slide 7 and apply. Okay, so this means that you'll just click on it, it'll take you right to that slide. Okay, so make sure your journal is up to date. This is what it should look like. You should have your cover. The blue journal is what we're working in now. Make sure your name is on there. Your table of contents, you should have Unit 3 objectives, Lesson 1, Lesson 2, Lesson 3, and 4. Your objectives should be in here. Here's Unit 3, Lesson 1. You should have filled in all of this with me from my notes. Unit 3, Lesson 2, you should have this filled in from my notes as well. I used Miss Robinson's video that day because I was having issues with my calculator on my computer. But you should have this filled in. And we should have these check marks filled in, and then you should have a picture of your notes where you solve this equation, or at least know how to solve this equation because you might have a question about it. And here we are in lesson 4. So here we go. We're going to graph inequalities. So I'm going to zoom in here. Right here, if you click on this little drop-down arrow by this magnifying glass, you can zoom in so you can see your slides better, okay? Okay, so when we're graphing inequalities, our graphs look a little bit different. They have this shaded area and our lines look a little bit different. So we're going to talk about those. First, our first step for graphing linear inequalities is exactly the same as graphing equations. So remember the difference between equations and inequalities. Our equations will have an equal sign, just like this right here. This is an equation, it's got an equal sign. Inequalities have these symbols, less than or equal to, greater than, less than or greater than or equal to, okay? So our first step is exactly the same as it was in lesson 3. We need to make this inequality look like y equals mx plus b. So we need to get y by itself. So I'm going to come over here to the side, and I'm going to solve the equation. Then I'm going to insert it onto my graph. So let's see, we have 2x minus 3y is less than 12. Okay, remember our steps for solving inequalities are exactly the same as solving equations. So I'm going to draw my line. I want to get y by itself, so I'm going to take this highlighter, I'm going to highlight. This is what I want to leave on the side of the equation by itself right now. So that means the thing that's not highlighted on that same side is what I'm moving to the other side. Since it's a positive 2x, there's not a negative sign in front of that 2. I'm going to use the inverse operation. So to undo something positive, I have to subtract it. So I'm going to subtract 2x from both sides. 2x minus 2x is 0. If you have 2 cookies, you eat 2 cookies, you have 0 cookies left, okay? So 2x minus 2x is 0, and all I'm left with over here is that negative 3y, and that's what I wanted. That's the thing that was highlighted, is less than. 12 doesn't have an x with it. These are not like terms, so I can't put them together. So all I have left over here is negative 2x. That's a positive 12, so I have plus 12. Okay. So now I want to get y by itself. So I'm highlighting y. That's the only thing I want on this side. So I want to get rid of the thing that's right there next to it. When you have a number and a variable right next to each other, that's multiplication. So I use the inverse operation. The inverse operation of multiplication is division. So to undo multiplication, I have to divide. I'm going to divide everything on this side by negative 3. So negative 3 divided by negative 3 is 1. So I'm just left with 1y, but I don't have to write the 1 in front of y. I understand there's 1 there. I divided by a negative number. So I have this rule that tells me if I divide or multiply on both sides of an inequality by a negative number, I have to flip my symbol. So now instead of having a less than, I'm going to make it greater than. So I have to flip my symbol, okay? Because I divided by a negative number, I need to flip that symbol. All right, so I have negative 2 divided by negative 3 is going to be positive 2/3 x. And then positive 12 divided by negative 3 is negative 4. So this side over here, I need to do negative 2x divided by negative 3 plus 12 divided by negative 3. You have to split that up and divide both pieces by that number, okay? We're dividing everything on that side. All right, so I have y by itself. I'm going to go ahead and screenshot this. And I'm going to insert image from computer. I'm going to go ahead and put my notes into my journal. So you can write that on paper and then just insert a picture. So from your Chromebook, if you wrote all this out on paper, you would go insert, image, camera, and then you can just hold your paper up in front of your camera on your Chromebook and it'll take the picture, insert it right into your slides, okay? So that's the easiest way to do that. You should have this in your slides. Okay, so once we have it, have y by itself, then we can move on in our process of graphing. So we need to know a couple of things here. We need to know the difference between if we're going to have a solid line or a broken line or a dashed line, okay? So that difference is when we have closed circles or open circles, it's the same. When we had closed circles, we said it was equal to. That point was included. And if we took a bunch of closed circles and put them all together, then they would make a solid line, right? So that means that we're going to have a solid line if we have these equal to symbols. So I'm going to put these equal to symbols. The less than and greater than are equal to. So if we have that equal to line underneath our symbol, then it's going to be a solid line. So that means that we're left with the other two symbols being broken. And that makes sense, right? We had open circles if they were broken, if they were not equal to. And so if you put a bunch of open circles next to each other, then this kind of looks like a broken line. That's what happens, okay? So if it's equal to, we have solid lines. If it's not equal to, we have broken lines or dashed lines. Then we need to decide if it's going to be shaded above the line or below the line. Because we solved to get y by itself, I can look at the equation and say, this is, for all my y values, bigger than this equation. And so that means we're going to be shaded above. This only works if y is by itself. You cannot look at the original equation right here and make that decision because you notice we flipped this symbol, right? We flipped the symbol and it changed the direction of the symbol, okay? So this only works if your y is by itself. Do not look at the original equation and say, oh, this is going to be shaded below, because it's not. We solved and it changed it, okay? So if it's greater than or equal to, then it's shaded above. It'll be shaded above. Remember, you have to be solved for y. Y has to be by itself to make this decision. So shaded below means it's going to be less than or equal to. I said those backwards as I was grabbing them. Less than or equal to or less than. Shaded above is greater than. Shaded below is less than. Okay? This only works if y is by itself. Okay? Cannot stress how important that is. It only works if y is by itself. All right. So let's graph this. Let's graph this inequality. So we have y is greater than. Are we going to have a solid line or a dashed line? Well, it's not equal to, so it's going to be a broken or dashed line. So I'm going to grab this little circle and say dashed line. You can resize this a little bit if you want. There we go, dashed line. Okay, and then is it shaded above or below? Well, it's greater than, so it's shaded above. So I'm going to take this and circle above. So we're looking at a graph that has a dashed line, so we're down to just these two, and it has to be shaded above. So I'm looking at this graph right here. That's got to be my option, okay? But I want to double check and make sure I'm right. So I want my slope. I'm going to look at my slope. Well, I've solved for y. M is my slope. That's the number right in front of x. So that means my slope is 2/3. So I can type in 2-3. My y-intercept is my b, and on my equation, that is, or my inequality, that is -4. So I'm going to say b equals -4. My slope is -4. I'm sorry, my y-intercept is -4. So my y-intercept is -4. So on my graph, I should cross at -4. Well, this is 1, 2. I'm going to assume that this graph is probably counting by 2. So this is -2 and -4. Okay, so this is crossing at b equals -4. And my slope is 2/3. Did I do that right? Yeah. 1, 2, 1, 2, 3. There we go, 2/3. That's another intersecting point. Okay, so this is my graph right here. So now I have this last little question. Oh, I got my little green arrow, my green check mark. We're going to go bring that down here. So this is my graph for this equation. We know it's shaded above. We know it's a dashed line. So this can't be it because that's a solid line. This can't be it because that's a solid line. And this can't be it because it's shaded below. Okay? So which of the following, and then we double checked our intercepts and our slope. Okay, now we want to know which points are solutions in the set of inequality above. So what I'm looking for is, are these points in my shaded region or are they outside my shaded region? So 0, 0, well, that's the origin. It's in my shaded region, so it's part of my solution. So I'm going to go ahead and say, yes, this one's part of my solution. Number 2, we have -4, -2. So 1, 2, 3, 4, 1, 2. Again, that's in my solution set. It's in my shaded region, so it's part of my solution set. Then we have +4, -2. So 1, 2, 3, 4, 1, 2. This is outside of my shaded area, so that is not part of my solution, so I'm not going to select it. The only thing we need to remember when we're dealing with is it part of my solution or is it not, is if we're on the line. If it's a dashed line, like this, a broken line, then they're not included. Okay, this is open circles, they're not included. Okay, it's not equal to at these points. It's not equal to. So if you're on the line, if you're given a point on the line, that is not part of your solution set. If it's a solid line, yes, it is part of your solution set. Broken line, not included. Solid line is included. Okay. And so other than that, you're just looking, is the point in the shaded region or not? If it's in the shaded region, you're good to go. It's part of your solution. If it's not part of your solution.